Hello everyone, welcome to Engineering Data Analysis. For this video, we would be talking about the introduction to engineering data analysis. In this chapter, we would be introducing the field of statistics and how engineers use statistical methodology as part of the engineering problem-solving process. After the end of this lecture series, you would be able to do the following. You should be able to discuss the engineering method. Number two, you should be able to differentiate the two methods of collecting engineering data. Number three, you should be able to know how to conduct a survey. And lastly, you should be able to identify the different variables in an experiment. To begin with, let us first talk about what is an engineer. As future engineers, you should be able to solve problems of interest to the society by the efficient application of scientific principles. As we all know, the job or the main objective of being an engineer is to be able to refine existing products or processes and design new products or processes that will meet the customer needs. In the beginning of 1980s and continuing up until the 21st century, an inordinate amount of attention has been focused on improvement of quality in our industry. Much has been said and written about the boom in the Japanese industrial advances or also known as the Japanese industrial miracle, which began in the middle of the 20th century. The Japanese were able to succeed where we and other countries failed, namely to create an atmosphere that allows the production of high quality products. As we all know, the technological advances in Japan is still quite far from what we have in the Philippines. These successes is actually attributed to the use of statistical methods and statistical thinking among management personnel. As an engineer, we always deal with data. And by using the data existing or the data that will be gathered, we should be able to use them in order to identify the customer's needs and to be able to create and refine products and processes in order to have a high quality uh, products and processes. In order to do this, we do what we call your engineering or scientific method. The engineering or scientific method is an approach to formulate and solve problems. In order to do this, we need also what you call your statistical thinking. So please take note that the engineering method and statistical thinking always goes hand in hand. The engineering method starts with developing a clear and concise description of a problem. In order to start any statistical thinking process and to use engineering method, the first thing that you need to do is to identify first a problem. After identifying the problem, you need to identify even tentatively the important factors that affect the problem or that may play a role in the situation. So what are the factors that will affect your problem? Even if you cannot identify all, you have to identify uh, a significant number of factors that will be uh, affecting our problem and how it will affect our solutions. Next, we will be proposing a model for the problem by using the scientific or engineering knowledge of the phenomenon being studied. We should also state any limitations or assumptions of the model. So after identifying the factors, you need to propose a model or a solution to the problem. You have to use scientific knowledges or engineering knowledge about the problem that we are solving and including the solution. Afterwards, we would be conducting appropriate experiments and collect the data to test or validate the tentative model or conclusions made in the preceding steps. So in order to validate your proposed model and how it affects or solves your problem, you need to conduct experiment. So that is part of our discussion today. How do we conduct experiments? Afterwards, we refine the model on the basis of the observed data. After conducting the experiment, you would be able to gather a data, and that data can be used to manipulate the model and to necessarily change the proposed model. Afterwards, we manipulate the model to assist in developing a solution to the problem. Okay, so as you can see, you have here the three blocks inside a broken line. This simply means that you are to perform these three processes continuously until such time that you now have a model that can actually solve your problem. In order to manipulate the model rather, you need to use the data gathered from your experiment. So, after manipulating the model, we will now conduct an appropriate experiment to confirm that the proposed solution to the problem is both effective and efficient. So, the solution now, or the developed model, will now be undergoing another set of experiments in order to confirm if it is effective, accurate, and efficient. And lastly, we will now draw conclusions and make recommendations based on the problem solution. As you can see, this engineering method features a strong interplay between the problem, the factors that may influence its solution, a model of the phenomenon, and experimentation to verify the adequacy of the model and proposed solution to the problem. So the factors that would be always affecting the engineering method is the problem that needs to be solved, the factors that affects your problem, the proposed model, and the verification, and finally the conclusion and then the recommendation. All of these steps should be followed by every engineer in order to efficiently plan experiments, collect data, analyze and interpret the data, and understand how the observed data are related to the model which we have proposed for the problem under study. So it is not enough to just know the problem, but you also need to know how to plan, to collect, and to analyze and interpret the data gathered. And by doing this, we can now refine our products and processes or create new products and processes as an engineer. The engineering field is composed of two important fields related to statistics. The first is the field of probability, which is used to quantify likelihood or chance, and it is also used to represent risk or uncertainty in engineering applications. As you can see, based from our processes, the engineering method still involves a repetition of processes because of various factors affecting our result. And that is always will include your risk and uncertainty. That's why as an engineer, it is always important to know how to assess risk and to make necessary adjustments depending on the risk studied. The field of probability will also help us and can be interpreted as our degree of belief or relative frequency. Because many aspects of engineering practice involves with data, obviously some of the knowledge of statistics is important to us engineers. Specifically, statistical techniques can be a powerful aid in designing new products and systems, improving existing designs, and designing, developing, and improving production processes. This is very important because the field of statistics deals with the collection, presentation, analysis, and use of data to make decisions and solve problems. As an engineer, you can never avoid data. There are a lot of data that will be thrown to you once you are now practicing engineering. That's why it is always to know how engineering data analysis works. Engineering data analysis is actually a science that will help you know how to properly and efficiently collect, analyze, and present data systematically. As part uh, as part of our job as an engineer, we are always thrown a lot of data, and if you don't know how to efficiently use them and to present them systematically, the data would be useless. Engineering data analysis also involves the process of collecting, processing, summarizing, presenting, analyzing, and interpreting of data in order to study and describe a given problem. As an engineer, you should know not only what the problem is, but you should also know how to process the data collected or the data available to you. Take note that a data that is not processed will always be a useless data. So engineering analysis is considered as the art of learning from the data. In our world today, collecting data is quite easy. But the challenge for us engineers is how do we process those data and how do we make them useful in our respective fields. And lastly, engineering data analysis can be regarded into three different studies. It can be regarded as the study of population. So you get data from your population. It is a study of variation or the changes in different successive observations of a system or phenomenon that do not produce the exact same result. So there are variations in the data collected. So you're going to find out what are those variations. And lastly, the study of the methods of reduction of data. So how do we limit the data gathered? Because sometimes too much data is also uh, not good, because too much data can actually affect your results. So sometimes too much data is good, but sometimes it can also be a bad thing, because too many data would also mean too many variables to be examined. So how do we use the data gathered in engineering method and statistical thinking? You can use it to make decisions. You can use it to solve problems. You can use it to design products and processes. Now, again, as an engineer, your job is to improve product design, test product performance, determine its reliability and maintainability, working out safer systems of flight control for airports or any other field of application. So the job of an engineer will always revolve about solving problems and designing products and processes that would help us live and have a more efficient life. And that will always involve data to be used to make decisions. So that's it for the introduction to engineering analysis, data analysis. In the next video, we would be talking about the different terminologies in engineering method.